In this video, we're going to be covering how you can write the equation of a parabola given three different points. Otherwise, target M7, sometimes it's called curve fitting. So first of all, let's go back a little bit and talk about doing curves between 2 points. You have the point 1, 0, and you have the point 2, 5. You're trying to figure out what curve can go in between those 2 points. And we've always known that 2 points create a line. Right, so a line can go through those 2 points, but it's clearly not the only equation that can go through just 2 points. For example, absolute value could be a graph that can go through those 2 points, or a parabola could go through those 2 points. So there's a lot of different curves that can go through 2 points, but we're looking for a certain type. So for instance, if I add a third point, 312, that's going to change things a little bit, because if I have that same line, 312 doesn't fall in it. That's why we've always said 2 points create a line. But 3 points, those 3 points have to be collinear, which they are not, so a line doesn't work. The absolute value isn't going to work then either, and clearly if you remember the parabola, that won't work either between those particular 3 points. So the parabola that you create between 3 points is a very specific parabola, just like the line that you would create between 2 points is a very specific line. So it's not just any parabola that can be created through 3 points. It's a very specific one, and so that's what we're going to be trying to find today. Here is a parabola that goes through those 3 points, 1, 0, 2, 5, and 3, 12. So we're going to be trying to find the equation of that particular parabola. So how do we actually do that? Let's find that parabola that goes through those 3 points. And how we go about it is by plugging points into the standard form of the parabola, y equals ax squared plus bx plus c. And that's because we have 3 points where we have an x value and a y value. X value, y value for point 2, and the third point is a separate x, y value, and x and y value, excuse me. So you use your y equals ax squared plus bx plus c, and you have your 3 points. So 1, 0, for example, you plug 0 in for y, 1 in for x, and you get something that looks like that. And for 2, 5, you do the same thing, 5 in for y, 2 in for x, and for the third point, same thing, 12 in for y, and 3 in for x. So just simply by putting in for x and y, and now we're able to simplify each. So the 1 squared and the 1, the 2 squared and the 2, and then we kind of write it in a better format where the coefficient goes out in front. And then your third one is 12 equals 9a plus 3b plus c. So that's just from your simplifying. Now what we see is that we have 3 equations with 3 variables. And in our last target that we've talked about together in this unit, we talked about finding the solution for a 3 equation, 3 variable systems. So that is what we're going to do next. We're going to solve this system of equations using our target M6 method, or just solving algebraically, essentially. So as we go to a image of how we actually solve that, if you recall that target, you pick any 2 sets of 2, and so I'm going to pick this equation and that equation, the second and third equation, and I'm going to find eliminate, in this scenario, the c first. So as we look at these, the c is going to be the easiest part for this target as to eliminate first. So you have a, b, and c are now our variables we're solving for. So sometimes students get a little confused by that, because they think it's always x, y, or an x, y, z. Now we have a, b, and c that we're solving for. I'm going to write these in a better order where we put the coefficients first. So we have 9a plus 3b plus c equals 12. And you have 4a plus 2b plus c equals 5. And I'm just going to subtract that entire equation. And so you finish out your elimination process, and the c's cancel. That was the point. And so we have 5a plus b equals 7. If I choose these 2 then, so the first and second as my second system, so you have 4a plus 2b plus c equals 5, and a plus b plus c equals 0. And again, we're just going to subtract that one. It's nice that those c's are the same. They're going to cancel out right away. And so now we have 2 equations with 2 variables, and so we're going to put those together, and so and then we're going to do our final elimination step. And as we do that elimination step, now in this case it's nice that the b's cancel out nicely when we subtract. So you have 2a equals 2, and we've solved to get a equals 1. Plug back into any one of these to find out what b is. So either one of those, I'll choose this one. So 3 times 1 plus b equals 5. So that means that b equals 2. Sorry, b equals 2 there. And now we have to solve for c. So you plug into any one of these three equations for when you're trying to solve for your c value. And this one looks the easiest. So I have 0 equals 1 plus 2 plus c. Therefore, c equals a negative 3. And you found your three solutions for your variables a, b, and c. And so when that comes back together, that tells us that our solutions for the variables a, b, and c, 1, 2, negative 3, and my equation of a parabola that goes through those 3 points is y equals 1x squared plus 2x minus 3. So the two big clues, solving for a, b, and c, and you eliminate the c's first. And here are the steps to find the parabola from 3 points, or also called curve fitting.